Hello, Legend of the Samurai here with an UrbanAlps Stealth Key. This is a interesting lock designed primarily for this key, which I literally cannot show you the bitting from any angle. This was the entire purpose of the design. The bitting surfaces are actually inside those grooves, which means that not only can you not see them from the outside, you can't actually mill them from the outside either, at least not in any practical way. So these keys are actually 3D printed, which means key control is top-notch for these. And in terms of the cylinder itself, they're also reasonably difficult to pick. They have 14 false-gated levers, 7 per side, each interacting with their own sidebar. And they are not entirely straightforward to get open. So I'll be using a flat tensioner in one side, and then a very thin little pick, it's about 1 millimeter in diameter, from the other side of the keyway, and due to the way it's designed, I can actually pick both sides of the levers from one side of the keyway. That will make much more sense once I have this apart and can show you how it works. But I will start in here. The left side binds first, so I'll be picking out of the right side of the keyway. Start at the back. 7 is set, 6 feels good. 4, click out of 5. 3 feels good. All right. 2, and that false set is actually the entire sidebar dealt with. Now if I go and I tap 1 on the other side, get a deeper false set. Now I'm in the false gates of the max lift levers over here. So 2 is binding. Three is good, 4 is good, 5 is bound. Right. 6 is good, 7 is bound. And there's our first stage of the open. And I say first stage because as the sidebars are independent, and there are 2 of them, they will relock as you go around, but I'm actually going to pick it full circle because there's an extra set of elements that you have to deal with. They're not difficult, but if you don't know about them, it's a little tricky. So right now the plug is free, and as soon as we expose the keyway to where the Bible is, 2 little pins spring up into the keyway and get everything stuck. Those are related to core retention, and I'll show them later, but for now, we just need to press them down with a flat pick, and then we get relocked again, so that's another sidebar. And because of the positioning on the sidebars, I'm only needing to pick one at a time now. So, pick this one first. All right, that's the left side done again, and now we just have the right side. go. And now we get caught on the pins again, so we just have to push those down. And there's our full circle. So, there we are. Now we get to take it apart. And I'm only going to mostly gut it. I'll leave the core intact. So first we need to drop out actuator in the back. And you want to be careful not to launch that little cam spring, exactly like that. Luckily it didn't go too far. And then we have a spacer ring. And now if we push this out of the way, we can get a clip off of here. It holds on very strongly. There we go. Yeah, so not your normal C-clip. It grabs onto the edge of a feature in the back. And if we pull the core forward a little bit, we can drop the actuator out. And so this is actually what those core retaining pins are doing. Normally, with a sidebar lock like this, if I just put in the key and pulled straight out, the plug would come with it. But that does not happen because there are two little pins holding it in place. So if I turn this slightly, then I can pull the core out. And I want to follow this to make sure those don't go flying, and hold the sidebars. All right. So here is our first sidebar. Set that down there. Take out our springs. And here's our second sidebar. Okay, so that's all the little pieces. And then before we get into that, we'll show these little pins in here come out. I can't actually get their springs to come out with them. Those seem to be fixed in place from the bottom. But those pins sit in these grooves. And because they are straight-sided, you can't pull the core out unless the cylinder or the plug is turned somewhat, which means you cannot gut one of these locks without a key or without it in the picked state. All right, so now the interesting bit is how the key interacts with all of these levers. So they are shaped with a curved surface on the opposite side, and so one lever, which interacts with the key over here, is actually for this sidebar. And because the side of the keyway is open, that is actually how I was using this thin pick. So I could get the right side that way, and the left side this way. So, how these work is, as you move the lever, you go past these true and false gates, and one of the design limitations on this lock is the fact that there are only 3 bitting heights in use. There is true zero lift, so if we look here, 3 of these out of 7, 1, 2, 3, I don't ever need to do anything to them. Now, if I do lift them, there are 2 false gates I can fall into. So they're not totally trivial. If you lift them when you shouldn't, they can cause you problems. But other than that, you don't need to do anything. Then we have this middle lift here, and it does not effectively have a false gate. You can't get below it, and the sidebar can't fall in on this little notch, and there is no separator beyond it, so you can't really overlift it either. If you let off tension slightly, you will always fall back to the true gate on the middle lift. On the maximum lift, you do have a false gate that you start in, and it has a wall between it and the true gate. So the only elements where the false gates actually matter at all, if you're picking carefully, are these max lift elements. Now, with 14 levers and only 3 bidding heights, you can expect on average to get 4 or 5 of each bidding height. So you'll only need to be picking probably 9 or 10 of the levers at all, and only 4 or 5 of them will have false gates to deal with. In this lock, I have 6 zero lifts and 5 max lifts, and only 3 of the intermediate ones. So I can show how this works with the key. So as this moves in, it pushes the levers up. And then if we look at one of the sidebar areas, as I slide this in, with the key in, all of the true gates line up. Do that on the other side as well. And with those in place, the sidebars can fall in. So these sidebars are fairly simple. They have a slightly reduced cross-section where they interact with the actual gates. And one of them, the second position on each side, is substantially narrower than the rest of them. I'm not sure why they do that, and it has corresponding cutouts. Maybe that's just a feature to locate this so they always know which side to put in a given direction. But it is symmetric front to back, so I can't explain why they do that. And the other sidebar is identical. And those interact with these 2 sidebar grooves, which are not 180 degrees apart. So that is why the sidebars relock independently of each other. But all in all, a very interesting lock. It's a fun thing to learn. It could have been much, much more difficult to pick if they used more bidding heights, and with that, it would allow them to have more effective false gates. The ones that do grab very nicely, and if you're not very careful with your tension, there can be a lot of ping-ponging back and forth. You may have noticed with this tensioner, I wasn't just pressing down on the end, I was pushing in a direction, and I've found that for various points on the lock, if you press down on the cylinder, away from the keyway, and then counter-rotate with the back of the wrench, it's actually much more consistent for setting them, because that will shift it ever so slightly and optimize the sidebar, but you'll need to play with it to figure out what an individual lock will need. So, all in all, a fun lock to pick if you can get one. They're not the easiest things in the world to get, but all in all, I would recommend them. So there we are, both sidebars, plug, and then once more there is our key. It is the UrbanAlps Stealth Key, picked and gutted. Thanks for watching, and have a nice day.